All right, guys, so this is our second Flip the Classroom lesson. It's going to be on synthetic division. We're going to say synthetic division is a kind of polynomial long division we can do when we are dividing a polynomial by a linear factor. So our divisor is a linear factor, and our divisor isn't just any linear factor. Our divisor is a linear factor of the form x plus a. Now that a could be a positive or a negative number, but the thing to take note of is that we have a lead coefficient of 1, right? So if that lead coefficient is anything other than 1, we have to go back and use polynomial long division to do this division out. Okay, so in the process of synthetic division, the first thing we're going to do is take our linear factor and solve for the 0. So with our first example here, we've got f of x divided by d of x equals x plus 3. So right here, from our linear polynomial, we can take the 0 of x equals negative 3. We're going to take that 0 and put it up in the corner right here. Now, from my polynomial, I'm going to take all of the coefficients, right? So right here, I am going to take the coefficients and list them next to the 0 of the linear polynomial that I'm dividing by. Now, just like polynomial long division, I need to make sure that all of my terms are represented. So right here, I can see that I don't have a quadratic term, and I'm going to represent that quadratic term with a 0 in the list of coefficients. So right here, I've got 1, 4, then it's going to be 0 for the quadratic term, negative 5, negative 20. Now, the process of synthetic division works like this. We drop the first coefficient, and then we multiply the 0 and the first coefficient to get the product that we are going to put underneath the next coefficient. So right here, I multiply the 0 and the 1, and I get negative 3 that goes under my next coefficient, and then I add vertically. So right here, I'm adding my coefficient with the product that I just got to get 1, and then I repeat the process. So it's multiply the 0 and the sum, take that product and put it underneath the next coefficient, and add. So right here, it's going to go negative 3, negative 3 times 1 gives me negative 3, and then I add vertically and I get negative 3 again, and then it's negative 3 times a negative 3 gives me a positive 9, and then I add vertically, and that's going to give me a 4, and then a negative 3 times a positive 4 gives me a negative 12, and when I add vertically right here, I get negative 32. Now, what we've got are the coefficients for the polynomial that is the quotient of the division of our f of x by our d of x, right? So what we've done here is divide a linear polynomial out of a fourth degree polynomial. So what we've got right here are actually the coefficients of a third degree polynomial, right? If I've got 4 linear factors from my fourth degree polynomial, and I divide 1 of them out, then I'm going to have 3 linear factors left, or a third degree polynomial. The last term right here is the remainder. So right here what we have is x cubed plus x squared minus 3x plus 4. That's the quotient, or the division of f of x by d of x. And then we have the remainder of negative 32. Now, just like with polynomial long division, there are 2 ways we can write this. We can write this in polynomial form, which would be a representation of our f of x as the multiplication of our divisor, x plus 3, times our quotient, x cubed plus x squared minus 3x plus 4, and then plus our remainder, which is a negative 32, so we could really say minus 32. And then we can also write it in fraction form, and of course fraction form is a representation of the division we've just done. F of x divided by d of x is going to give us right here the quotient, x cubed plus x squared minus 3x plus 4, and then that remainder of negative 32 is still being divided by our divisor, x plus 3, so we can call this plus negative 32 over x plus 3, or minus 32 over x plus 3. All right, so right here, we have an example for you guys to try. It's the same polynomial, but now we're dividing it by x plus 4. So why don't you guys pause the video and give this one a shot. Okay, so right here, we're basically doing the same thing. I'm going to take the 0 from my linear factor. So that's going to be x equals negative 4. I'm going to set it up over in the corner over here. And then I'm going to take the coefficients from my dividend. Now again, I'm going to represent the quadratic term with the 0 coefficient. So I'm going to have 1, 4, 0 for my quadratic, negative 5, negative 20. Then right here, I'm just going to go through the process of synthetic division. So we always drop the first term, and then we multiply diagonally and add vertically. So right here it's negative 4 times 1 gives us negative 4, and then we add positive 4 and a negative 4 gives us 0. Negative 4 times 0 gives us 0. Add and we get 0 plus 0 is 0. Negative 4 times 0 gives us 0. And negative 5 plus 0 gives us negative 5. Negative 4 times negative 5 gives us a positive 20, and when we add these two guys, we get 0 for that last term. Remember that this is the remainder, so what we're seeing here is that x plus 4 is a factor of f of x. It's one of the 4 linear factors that we would have to multiply in order to get the 4th degree polynomial f of x. And what we have left over as a quotient is x cubed minus 5, right? And that's basically going to be made up of the other 3 linear factors that we would have to multiply in order to get the f of x, if we multiplied that by our d of x. So right here, looking at this, we can represent it in polynomial form. So f of x equals, and then it's the quotient, or not the quotient, but I'm sorry, the divisor, x plus 4 times the quotient, minus x cubed minus 5, and then plus the remainder, and there is no remainder. And what we're saying here is when we multiply this linear factor by this cubic, which is made up of the other 3 linear factors, we're going to get back to our f of x, right? Now, I'm representing the multiplication with the divisor first and then the quotient, but it really doesn't matter what order you write them in, because multiplication is transitive. It works well. It works the same in either order. All right, so fraction form is again going to represent the division that we've just done. So when I take f of x and divide out the linear factor of x plus 4, I get the quotient x cubed minus 5, right? And basically that is the other 3 linear factors left over when I divide out my x plus 4. Okay, so we're going to go ahead and talk about 2 other theorems. We're not really going to use these other theorems, but it's worth to stop for a second and take note of them before we move on. These 2 theorems are pretty closely related: the factor theorem and the remainder theorem. The factor theorem states that if f minus k, the linear factor f minus k, is a factor of f of x, then f of k equals 0. The 0 that we get from our linear factor, when we plug it into the function, we're going to get 0. Now this should make sense to us on a couple levels, but on the most basic level, if this is a linear factor that is one of the linear factors of the function f of x, then its 0 represents an x-intercept, or a function value of 0. So when I plug in that x value, I should get the function value of 0, which is going to be the y value when I'm on the x-axis. So right here, we can use the example that we just saw to show this works. Right here, we'll take the 0 from our x plus 4. That's going to be x equals negative 4. We plug that into our function. We've got f of negative 4 equals, and then negative 4 to the 4th power plus 4 times negative 4 cubed minus 5 times negative 4 minus 20. Now right here, this is going to be 256, and then this is going to be a minus 256. Then we've got negative 5 times a negative 4 is going to give us a plus 20, and then minus 20 equals 0. So there's our remainder, or there's our 0 that we will get, because we know that x plus 4 is one of the 4 linear factors that makes up f of x. The remainder theorem states that if a polynomial f of x is divisible by the linear factor x minus k. Then the remainder is f of k. We just saw this, right? We know that x plus 4 is one of the linear factors of f of x, right? So f of x is divisible by x plus 4. So right here, when we plugged in the 0 of that linear factor, we got a remainder of 0, right? And right here, when we do this, we can take a look at our first example with synthetic division. Take the 0, x equals negative 3, plug it into f of x, so we get f of negative 3 equals negative 3 to the 4th power plus 4 times negative 3 to the 3rd power minus 5 times negative 3 minus 20. And right here, when we do this out, we're going to get 81 minus 108 plus 15, and then minus 20, and that is going to give us a negative 32 once we add up all those together, which we knew to be our remainder from our synthetic division above. So one of the things that we can sort of point out here is that the factor theorem and the remainder theorem are really telling us something that we can find out just as easily with synthetic division. And in general, what we're going to say is we'll use synthetic division instead of these theorems because it's a little bit faster, and it also gives us the quotient as well as whether or not the linear factor is one of the factors that makes up our polynomial. All right, so that's the end of this video, guys. We are going to go ahead and look at the next video that is going to cover the rational root theorem.